Hello everyone, let's talk about MedSort. MedSort follows the concept of divide and conquer, where we divide the array into possible subarrays, then we apply sorting. Let's see how can we do that. You will be given array of length 4 which can be divided into two equal subarrays, where the left subarray contains 5 2, right subarray contains 3 1. So first we solve the left subarray, then we move on to right subarray. Now left subarray can further divide it into two subarrays which is 5 and 2. Now we cannot divide the subarrays furthermore, so that it's time to apply conquer. So as part of conquering logic, we compare left array elements with the right array elements, then we apply sorting. Now after comparing element 5 with element 2 is smaller, so we copy element 2, then we copy element 5. With this, we are done with sorting left part of the array. Let's move on to right part of the array, which can be further divided into 3 and 1. Then we apply conquer logic. After comparing 3 with 1, so 1 is smaller, so we copy 1, then we copy 3. With this, we are done with sorting of left subarray and right subarray individually. Then we apply conquer logic on both the arrays. So we compare left array elements with the right array. So by comparing element 2 with element 1, we see that element 1 is smaller, so we copy element 1. Then compare element 2 with element 3. Element 2 is smaller, so copy element 2. Then compare element 5 with 3. Element 3 is smaller, copy element 3. Finally, we copy element 5. So with this, we are done with sorting. Let's talk about time complexity. In MedSort, understanding the time complexity is little tricky. Let's see how to analyze it. So, in any algorithm, while analyzing the time complexity, pick up the complex operations. In this use case, the complex operations are conquering logic. So, as part of conquering logic, first we compare, then we sort. So let's see here, at this level we have total 4 comparisons, and at this level we have another 4 comparisons. So total we have 8 comparisons, which can be further divided into 4 into 2. So I can written it as 4 into log 4 base 2, where 4 is length of the array, so that I can say it as n into log n base 2. So the time complexity will be n log n. Let's talk about space complexity. Throughout the algorithm, even in worst case, at max you can take 3n space to solve the problem with MedSort. So that space complexity will be big O of n. So let me walk through the code. So you will be given an integer array. So first we apply divide, then we apply conquer. So as part of divide, you will be getting input array. So first we take up the length of an array. If the array length is 1, so we just return the array, because you cannot divide the array if length is 1. Then we take up the left array by dividing the current array, taking the elements from 0 to n by 2 index. Similarly, right array by dividing the current array, taking the elements from n by 2 to nth index. Then we apply conquer logic, passing left array and right array individually. So let's talk about conquer logic. So as part of conquer logic, you will be getting two arrays, left array and right array. The left array length will be m and right array length will be n. Then our result array length will be m plus n. So we initialize left index as 0, right index as 0, then result in index as 0. So we iterate until left index less than m, right index less than n. We compare left index value with the right index value. If it is smaller, we copy left index value to the result array. Otherwise, we copy right index value to the result array. You know that when the array size is odd, any one of the array is greater, so that if the left array is greater size, then we copy left array elements to the result array. If right array size is greater, then we copy remaining right array elements to the result array. That's it. Finally, we return result array. That's it. So that's how the MedSort works. So before submitting the code, let me walk through few more analysis of MedSort. So we discussed about time complexity and space complexity. Then talk about, is it in place or out place algorithm? Obviously, MedSort is out place algorithm because we are taking the elements into external array, then we are applying sorting. Let's move on to stability of a MedSort. Stability comes into picture whenever you have a duplicate keys. See here, you have a duplicate keys one with different property. Here, the red one came after blue one. Let's see, after applying MedSort, is it preserving the order or not? Yes, after applying the MedSort as well, the red one came after blue one, so that it is preserving the order. So the stability of a MedSort is stable. And MedSort is very good in external sorting. It means you can apply on internal sorting as well, but when the data size is very huge, you cannot perform sorting at internal level or RAM level. So we need to perform sorting at disk level. So MedSort is very much recommended for solving the problems on external sorting. So and MedSort can be achieved with a recursive way. That's it. So let me go and submit the code. Yeah, so here is the code which I walked through earlier. So let me submit. So that's it. So thanks for watching. My name is Srinu. I see you next time.